Hi, this is Mike, and I'll be demonstrating how your IT admins can seamlessly get access to the different targets they need, whether they are hosted on-prem, in the cloud, or even SaaS applications. During this demo, our IT admin will be utilizing the CyberArk Secure Browser. The Secure Browser simplifies the user experience while providing security against pre- and post-authentication attacks. More on this throughout the demo. To begin, the IT admin launches the Secure Browser. Notice that the user experience is identical to other browsers. The IT admin will log into the CyberArk Identity Security Platform using passwordless authentication by scanning the QR code. But third-party IDPs are supported as well. Once authenticated, the user is provided a list of web applications they have access to. They'll open up ServiceNow to see if there are any incident tickets to be worked, and sure enough, we'll see that there is an open ticket. Upon opening the incident ticket, we'll see that latency has been reported in the My App application. The ticket provides a list of resources to be checked to see if the latency persists. This includes Linux, Windows, cloud services, and databases. The IT admin will begin by checking to make sure that the Linux VM is operating as expected. Using his native tool of choice, all the IT admin needs is the target name. In this case, it will be the instance ID, as this is an AWS EC2 VM. Once they initiate the connection, they'll be prompted for their password and MFA. Now, this is their daily password. They do not need to worry about checking out a credential, managing credentials, or shared credentials here. We would also support a third-party IDP in this flow. Once they have been authenticated, they can choose to either log in with a AD account if you're using AD bridging on these Linux machines, or they can be logged in dynamically with the appropriate account to complete their task. This is happening just in time with zero standing privilege access by signing a short-lived certificate only good for this session, and then it's destroyed. There is no SSH key or password to this account. Now that they've been logged in, they run a couple commands to check to make sure the machine is responding as we expect. Everything looks good, so we're going to go ahead and exit out. Let's continue on and validate that our Windows system is working as designed. Because our IT admin has not connected to this system before, they'll simply grab the FQDN and use our connection guidance page to build the RDP file. Native tools are supported here as well, so this connection could be saved into a remote desktop manager tool of choice. Our user will enter in the FQDN and select if they choose to connect using zero standing privilege or vaulted credentials. Both are supported. The RDP file will download and auto launch. At this time, the ephemeral account is being created behind the scenes. There is no stored credential, managed credential being used here. It's being created at the moment of this session. In the bottom right-hand corner, you see that there's 2 hours allowed here, and at the end of those 2 hours, the ephemeral account is going to be deleted, and the access will no longer exist. Once the user has completed the login process on the machine, we can see that they can now go and complete their troubleshooting task. In this case, they'll launch Task Manager to identify if there's any memory or CPU issues. Upon looking at Task Manager, we see both look pretty good. CPU and memory usage is not out of the norm, so their troubleshooting task has been completed. Now let's assume for a minute our IT admin decides to do something they're not supposed to do. They're going to go and download some unapproved software. However, our organization is enforcing least privilege on endpoint computers and servers, reducing the risk of information being stolen or held for ransom. Let's see this in action. In this particular example, our IT admin will go to download Notepad++. This software is innocent enough, but if it was downloaded from the wrong location, it could be malware, so it's important unapproved downloads like this be restricted. Upon running the download, we see that the system has recognized this is unapproved software. It recommends an approved software store, but it also will block installation until this has been approved by the appropriate system administrator. Our IT admin has completed his task on this system, so he decides to move on. As we return back to the ServiceNow ticket, we'll see the next task is to log into a particular AWS account and verify that the EKS cluster is still active. To do so, we can Improve the user experience by using the CyberArk Secure Browser Productivity panel. No need to navigate to a different web page. We have our SaaS applications as well as privileged accounts the user has been granted access to use right here on the right-hand side. Additionally, we're able to enforce session recording natively in the web browser to provide audit of the session. Our user has the ability to gain zero standing privilege access to specific AWS accounts and permission sets, but the ticket explicitly stated to use the admin access permission set for the DevOps account, which is only available through approval. So let's submit that approval request. We'll state a particular reason. We see that we're doing my app troubleshooting, and we're going to reference the ServiceNow ticket specifically. Additionally, we'll now state the individual AWS account we're requesting access to and the permission set that's needed, which is the admin access permission set. We are pulling this directly from the cloud service provider. In this case, it's AWS. Finally, our IT admin will specify when they need this access. It could be in the future for a change management request. Since we are doing incident troubleshooting here at 8 p.m. At night, we're going to request it currently for a 2-hour window. At this point, when they click submit, it's going to go through the appropriate workflow. It could be Slack or Teams, which is what we're using in this case. We also have ServiceNow integrations. You could customize this through API flows as well. In Teams, we can now see that the appropriate approver would be a different person than the IT admin, of course, receives the request in the channel, can review the specific requirements around that request, and go ahead and approve it. The end user, the IT admin, will then receive an email that the request has been approved or denied, and at that point, they'll relaunch the web application. We'll enforce the session recording, and we'll then see that the user now has the additional permission called admin access at the DevOps account for the 2-hour window that it was requested. It's only at this moment when they click connect that we're actually reaching out to the AWS environment and adding the permissions onto the user's identity. It did not exist in AWS until this moment, and when the 2-hour window expires, those permissions will be removed. Now that the user has that access, we can see they can go in to the console specifically, or they could grab an access key if they choose to work via the CLI. This IT admin will want to use the user interface. We're going to be logged in. We have a little window in the bottom right-hand corner showing that the session recording is taking place. And now we're able to navigate to the Elastic Kubernetes service to verify that our cluster is active. We have a couple extra pop-ups that AWS is providing here, at which point the available clusters do load. We can take a look here and we can see that it is active. There are no warnings that we need to be worried about. And so we have now validated that the clusters are running as desired. All right, let's clean up some tabs here, see what's next on our list. Last but not least, we'll validate that the application's Postgres database is online and available. Access to the database is granted via zero standing privileges, and our user can quickly request a short-lived token via the CLI to access the system. At this point, our IT admin could simply utilize pSQL in the CLI itself or use their DB client of choice. In this case, they'll be utilizing dbeaver for this connection. This is a database our IT admin connects to frequently, so they've saved the connection string for ease of use. They don't have any saved credentials, however, since this is ephemeral access, so when prompted for their username and password, they'll simply use their username and the short-lived token they generated a moment ago that's only good for a particular period of time. At this point, they're being authenticated, authorized, and the ephemeral credential is being created. Although it appears native to the end user, they're accessing the database through the CyberArk gateway, so there's no need to expose the database for direct access, and there will be audit of the session as well. Now that we have access to the database, let's go ahead and run a query to verify that the database is responding, and we'll also take a look to see who we're connected in as. Our user will run the select current user query, which of course will return back the logged in current user. We can see this is not a federated identity, but rather the ephemeral user that was created for this particular session. At the end of the session, the credential will be deleted, taking us back to zero standing privilege. At this point, we've completed all the steps mentioned in our troubleshooting ticket. To recap, Our IT admin was able to securely and seamlessly access an array of targets, both on-premise and in the cloud, natively with their tools of choice. Now we'll flip over to take a look from an auditor perspective. Audit is, of course, a critical component to any privilege access program. Using the audit service, the appropriate teams can review exactly what access was granted, when, and to whom. Additionally, this information can be fed to a SIM. Let's look at the type of information we have one by one. If you'll remember, our IT admin was connecting from a Linux EC2 instance to a Windows machine to an AWS account to a database, and we have all those sessions registered here. If we start with that EC2 Linux access request, we can see who the user was, what system they connected to, at what time, and what specific commands they ran. If they had run a whole bunch of commands, it could be a lengthy list to look through, so we could actually utilize our beta capability to have AI summarize exactly what was done in that particular session. This is a great tool for any auditor to utilize. Let's go ahead and take a look and see what exactly was done in the Windows session. Similarly, we can see the target system they connected to, who the user was, as well as the ephemeral user that was created and utilized for that particular session. Remember, that ephemeral user gets deleted afterwards. We have all the commands they ran, and again, we can utilize AI to summarize exactly what was they done, and AI calls out that the user tried to download and install Notepad++, but decided not to. As we look at the AWS console access that was utilized, we can see that they requested admin access. We'll follow up on that in just a moment to see further. Now we're taking a look at the database request and what was done in that session. We can see the specific database that was connected to, as well as the commands that happened in that session. Remember, we have all this audit even though the end user was able to natively connect through their tools of choice without having to jump through proxy servers or jump hosts. Now let's go and take a look at the audit we're able to gather for web applications specifically. As we navigate to this particular page, we'll see we need to decrypt the recordings by scanning a QR code and biometrically authenticating in a web application. At this point, we can see the different web application sessions that have been recorded. We have different apps like Salesforce, Azure, and the AWS Identity Center console session that we recorded just a few moments ago when our IT admin went to check the EKS clusters. We can click through screenshot by screenshot of the different things that were clicked on, typed on, or hovered over, or we can utilize our filter search here to search for particular keywords. We can jump immediately to the EKS cluster to see what they were doing in this particular moment of their session. Very powerful stuff.